This lesson will teach me to determine if figures are similar to each other and use the definition of similarity to find the value of missing variables. Some definitions. Similar figures. In order for figures to be similar, we need to have all corresponding angles congruent and all corresponding sides being proportional. Taking a second to talk about the notation for similar. It's this little squiggle. When we talk about congruent notation, we used the equal symbol and the similarity symbol because in congruence we had the same size and the same shape. However, in similarity, we don't have the same size, we only have the same shape. So when we talk about angles being congruent, looking at the diagram right here, and feel free to add it to your notes, it says that triangle ABCD, we have the single little similar squiggle here, is similar to figure GHIJ, meaning angle A is congruent to angle G, angle B is congruent to angle H, angle C is congruent to angle I, and angle D is congruent to angle angle J. So all the corresponding angles are congruent. A with G, B with H, C with I, D with J. And notice the markings. 2 is different than it was for congruence. In congruence, we had all the corresponding sides to be congruent. Here, the corresponding sides need to be proportional, meaning that all of their fractions are equal. So the length of side from A to B has to be proportional to the length of side from G to H. Notice the fraction. The fraction representing those two lengths has to be proportional to the other. Notice the side lengths aren't equal, their fractions are equal. So thinking 1 over 2, 5 over 10, 3 over 6, 4 over 8, all of these fractions reduce to be the exact same fraction. A similarity statement is this right here. The similarity statement is very similar to the congruent statement. Here is the similarity statement. It lists the order of the vertices so that the congruent angles are in the same order for each shape. Noticing also that it has that squiggle in between, that's the symbol for similar. The similarity ratio is the ratio, a ratio is a fraction, of the lengths of the corresponding sides. This fraction results from setting up your extended proportion here. So as you set up the fraction of each corresponding side length, all of these will reduce to something. So in the example I just erased where I had 1 to 2 and 2 to 4 and 3 to 6 and 5 to 10, all of those would reduce to the exact same fraction, and that fraction is the similarity ratio. So number 2 is asking, are the triangles similar? If so, write a similarity statement. In order to determine if figures are similar, we need to first find two things. 1, are the angles congruent? And 2, are all the sides or the corresponding sides proportional? And this symbol represents proportional. So let's look at the angles. I have the double marking, I have the single marking, and using vertical angles, I'm going to use a triple marking. I can show that indeed all the corresponding angles are congruent. Now let's check that the corresponding sides are proportional. So let's follow the side length. I have the side length marked with a 10. It goes from the single curve to the double curve. On the other triangle, that corresponding side is 15. Set up that fraction. Pick another side. The 16, for instance, goes from the double marking to the triple, and on the other triangle, that side length is 24. And lastly, we have 12 to 18. All three of these fractions reduce to 2/3. This equals 2/3, this equals 2/3, and this one equals 2/3. So this is a similarity ratio. Because it has a number that all of these reduce to, that means that the corresponding sides are proportional. So are these figures similar? Yes. So the similarity statement would be, and you can go in different orders as long as they're the same for what you pick. I'm going to go A, C, B is similar to triangle. I went single, double, triple, single, double, triple. E, D, B. Looking at the second one, are the figures similar? Well, to determine that, we need to check two things. One, are the corresponding angles congruent? And two, are the corresponding sides proportional? And again, that's the symbol for proportional. So let's look at our angle markings. I have the singles that match with the singles. There's a single, double, and then 90 degrees. So yes, my corresponding angles are congruent. Now, for corresponding sides being proportional, let's set up all of these fractions. A 9 to an 18. I have a 9 to another 18. One more 9 to 18. And then the 5 to 12 and the 5 to 12. Well, 9 over 18 for all three of these reduces to 1/2. However, 5 over 12 does not equal 9 over 18. So no, the corresponding sides are not proportional. So no, these figures are not similar. So I cannot write a similarity statement here. The idea of similar is like that of a dilation. In order for figures to be similar, you're looking for essentially the scale factor, which we call here the similarity ratio, that shows how much a figure has been blown up or reduced. Number 3, here you've been given a similarity ratio, and these are important because notice the diagram has no markings. What this is telling you is that angle R and angle X are congruent. I'm going to mark them with a single marking. It's telling you that angle S and angle Y are congruent, so I'm going to mark those with a double. And then it's telling you that angle T and angle Z are congruent, I'm marking those with a triple. It's stating that those are congruent. Likewise, it's stating that the side length from R to S is proportional from the side length from Y to Z. R to S is 30, Y to Z is 12, and you can go through the triangles and set up all of these proportions. Oops, that's not 12. Let's try this one more time. So if I look at this diagram, the single to the double marking, single to the double marking, setting up that fraction, I'm going to do the single to the triple, single to triple, and now let's check triple to double, triple to double. So it's asking you to find the value of x, and I have 3 different proportions. You only need to pick 2. So if you want to pick those 2 to solve, you'll get the exact same answer as somebody who picks these 2 to solve. But we need to cross multiply. So I'm going to use these 2 since they're next to each other. 25 times 12. Let's see, 25 times 12 is going to give me 300, and it's going to equal, multiplying the other way, 15 times x, so x equals 20. If you wanted to use a different proportion, we could have used the 30 over the 18 equaling x over 12, and it should give us the exact same thing. 30 times 12 equals 360, divided by 18 gives us 20 as well. So there are multiple different ways to use these fractions and set up these proportions. Problem 4 is stating that the trapezoids are similar. It's asking for the similarity ratio. Oops, I don't think I finished the last one. The last one was asking for the scale factor or the similarity ratio. The similarity ratio would be, let's see, reduce 30 over 18, 25 over 5, and now we know that x is 20. The similarity ratio is a fraction that all of these reduce to, which would be 5 over 3. Is the similarity ratio. to get from one to the other. So think about a dilation there. So number 4, it says the trapezoids are similar. Find the similarity ratio, find the value of the variables, and write the similarity statement. All right, so the similarity ratio is in comparing our sides. Notice for a moment the little tick marks that these are referring to inches versus feet. So this is really a 12. Thinking about 8 inches and compared to 12 inches, I could also compare the 4 to the x, and here is a proportion that I can cross multiply. Before I do so though, if I'm able to set up the fraction as 8 over 12 and I'm told that the figures are similar, 8 over 12 is a similarity ratio, so reduced, it's 3/4. To find the value of that variable x, I'm going to cross multiply, so it gives me 8x equal 36 here, so, oops. 48 divided by 8, x is going to give me 6. In order to find the value of y is going to be an angle. Because it told me that the trapezoids are similar, I know that corresponding angles are congruent. So this angle here should match this angle here. One thing, and it looks like my little arrow is missing, these arrows, if you recall, mean parallel lines. When we have parallel lines cut by a transversal, we have some special angles. I see that I have same side interior angles. If lines are parallel, then same side interiors are supplementary. Given that this angle given is 129, its supplement would be 51. Since the trapezoids are similar, the corresponding angles are congruent, so y is equal to 51. A similarity statement is you stating the order of the vertices. So A, B, C, D is similar to E, F, G, H. For letter B, it says find the similarity ratio. Find a side length. Let's see. Well, I can compare the y to the 5, but it's not going to help me with the similarity ratio. I can compare the x to the 7.5, but again, not going to be helpful because of the x. What you really need to consider here is that there are 2 trapezoids, the one with a side length of 6 over here, and then there's this large one with a side length of AD as 9. So the similarity ratio is a reduced fraction of 6 over 9. So it happens that 2 problems in a row have a similarity ratio of 2/3. Finding the value of the variables. Now that I have the similarity ratio, I can set up a fraction. 2/3 is the smaller to the larger, so I can say that 2/3 is going to also equal y over 5 because it has the same similarity ratio. That's a y. So when I cross multiply, I get 10 equals 3y. So divide both sides, y ends up equaling 3 1/3. Then I can set up another another proportion for x. I'm going to use this 2/3 again. 2/3 is the ratio from the small to the large. So from the small to the large, my proportion will be set up in the same fashion. 2 times 7.5 is 15. Divided by 3, x equals 5. And if you want to plug these back in and check, what did we say? 3 1/3. That the fraction 3 1/3 over 5, 5 over 7.5, and 6 over 9 should all give you 2/3. A similarity statement states the order of the vertices. So if I start with trapezoid D, E, F, G, the larger trapezoid would go D, A, B, C. You can choose a different order to go in. And I believe that completes this half of the notes for similar triangles. Thank you.